Why, hello there, my pretty, and welcome to the ooky spooky, brilliantly bewitching world of compound inequalities. Ooh, okay, trying to do a witch's voice while getting over a cold, maybe not my brightest idea. But hey, I'm nothing if not dramatic. And honestly, I'm being kind of dramatic with the way I'm talking about compound inequalities. Anything new can seem a little scary, but I promise this isn't actually all that sick and twisted. Compound inequalities really aren't all that different from everything we've been doing. They rely on all the same ideas and choices for all the same reasons. And you'll find out, if you've been paying attention, a lot of those are actually pretty intuitive. So have some faith in them, have some faith in yourself, and I promise that you won't be led astray. Let's talk today, Class 6, Unit 2, about some compound inequalities. And if we're going to do that, probably might behoove us to know what a compound actually is. So when you hear the word compound, what are some things that come to mind for you? Take 20 seconds, pause the video. What do you think of when you hear the word compound? Go. And stop. Well, for me, I think of like when I hear the word compound, something like a building compound. Or maybe like, if I'm thinking scientifically, a molecular compound. Or maybe if I'm feeling real Englishy, like a compound sentence. No matter what you think of, it should hopefully cue you into the idea that we're working with more than one or multiple of something, right? A building compound contains multiple buildings. A molecular compound contains two or more molecules bonded together. A compound sentence contains two or more phrases, usually joined by some kind of punctuation mark. In English, we have two main clue words that often will tell us that we're working with a compound. In other words, right, something with two or more ideas, or things, or parts, or options, or choices. What are those two big words that come to mind for you? There are a lot of them, but two of them should stick out more than others. Take 10 seconds, pause the video. What do you think? Alrighty, maybe you think, maybe you think, maybe you thunk. I don't know. The two words in math that we often use to represent a compound idea, something with multiple parts. Well, I could say that I'm working with this and that. Excuse me, I'm dying. So there's your first one. The other one that you might see, well, if I'm not saying I have this and that, I might say that I have this or that, right? So this and that meaning I've got both of them, this or that meaning I've got at least one of them. In math, these ideas appear so frequently that we actually have some symbols, some algebraic representation, that corresponds to them. The first symbol for and that you might see looks something like this. It's kind of like an upside down V, but I often think of it, because it's connected to the word and, as like an A without a bar across. That's how I remember. It's actually a logical symbol. You'll see this when you get to geometry and you start writing some proofs. The symbol that we use in algebra more often is going to look instead like this. It's a little bit more rounded. It's kind of like an upside down U shape. It's not like disproportionate in that way. It's actually like a straight up upside down kind of U. For or is the opposite of and, so you might not be surprised to notice that its symbols are opposites as well. Well, the opposite of like this upside down V shape, for or I can use a kind of right side up V shape. Again, this is a logical indicator. You'll see it once you get to geometry and start some proof writing. But for algebra, we often use instead the kind of opposite of that upside down U, so it looks kind of like a right side up U. We'll talk about this a little bit tomorrow, and you might see this once you get into upper level math, but these symbols also mean something, just like that kind of no solution symbol or that all real number symbol meant something. This symbol on the left for the and symbol, this actually translates to intersection. So once you get into like probability, for example, the intersection of two things, if something lives in the intersection, it lives in both of them. This regular side up U symbol, it can mean union. And if something lives in the union, specifically of two sets, right, it lives in at least one of them. It could live in one, it could live in the other, or it could live in both of them. We won't use the words union and intersection too much in Algebra 1, but again, a lot of this is exposure, so the next time that you see it, it at least feels a little familiar. Cool, that's great and all, but what does any of this actually mean for us when we're solving inequalities? Well, so far, we've only seen inequalities with one criteria, just greater than, just less than or equal to, but that won't always be the case. So to get us thinking about where and why not, Well, maybe you can think of some like and or cases that might involve an inequality. Where do you think it might be powerful to have the ability to represent something using two or more inequality statements, either this and that, or this or that? Take a minute, pause the video, maybe look some stuff up on Google. What might be some cases? If you don't come up with any, that's totally fine. I'll give you a couple, but I want you to rack your brain. Think, 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 think. Go! And brains off. Just kidding, your brains are on, but your talking is done. So in this case, let's say, I'll give you two examples here. Maybe I want to talk about like age. And maybe I'll represent my age in years, so I'll use the variable y. Let's say that I want to talk about maybe the ages for which I'm considered a teenager. Well, if I am a teenager, what are my options? I could be like 13, 14, 15, 16, 17, 18, or 19. So I have to be at least 13, but as soon as I hit 20, I'm no longer a teenager. How could I represent that in symbols? What do you think? Is that going to be an and or an or? And then you know, for example, how to translate at least 13 in symbols. What two inequalities might represent this? Go. 5, 4, 3, 2, 1. Well, hopefully you come up with the idea that my age in years, if I'm at least 13, I could be bigger than 13, or I could be equal to 13. But I also must be less than 20. So I need to be both bigger than or equal to 13, and I've got the symbol, might as well use it. I also must be less than 20 to be a teenager. I could also take like the flip side of this. What if I'm not a teenager? Well, then what are my two options? Either I'm younger than 13, right? So I would say I'm less than 13. Or if I'm not younger than 13 and I'm not a teenager, then I would have to be 20 or older. So I'm greater than or equal to 20. So those are my options. You might also notice, right, they're totally flipped here. Another option that I could give you to kind of motivate this idea, what if I'm talking about temperatures? Specifically, maybe I'm talking about temperatures as it relates to states of water. I don't know, something random. I'll use Celsius here because the numbers in Celsius are actually quite nice. Boiling point in Celsius is 100 degrees for water. Freezing point of water is 0 degrees Celsius. So what if I want to talk about the points where my water is a liquid? Well, I would need to be between boiling and freezing. So same idea, the temperature in Celsius has to be less than 100 degrees Celsius. Otherwise, if I'm at 100, I'm at boiling. But I also must be, so I've got an and statement, greater than 0, right? If I hit freezing point, then I'll freeze. So I've got to be both less than 100 and greater than 0. And then I could also think, well, what are the places where I'm not a liquid? Well, hopefully it seems kind of intuitive here. Well, either I'm at boiling point or above it, so I'm greater than or equal to 100 degrees Celsius, or I can't be both at boiling and at freezing, right? I would have to be either greater than or equal to 100 or less than or equal to 0. So there's your idea, right? Some possible scenarios where these compound inequalities might show up. But what if I want to think about graphing these compound inequalities? What would they look like? So with that in mind, take a look at these three graphs down here. I'm going to tell you that all of them contain two inequalities simultaneously. Some of them are and statements and some of them are ors. We'll look at the x1 and the n1 together and then I'll set you loose on the last four. Take 30 seconds in game plan. Look at the x, for example. Look at the n1, for example. What two statements are being combined? And am I using an and or an or to combine them? What do you think? Take a risk, take a chance. Who cares? Go ahead, play around. And stop your playing. So look at our x here. Well, I see a -6 and a 3 in a circle, so both of these are either greater than or equal to. Let's look at the -6. So I'm talking about values of x. In this case, I've got an open circle around the -6, and then I shaded in stuff to the right of negative 6, that tells me that my values of x are greater than negative 6. But I also have values of x that are bounded by that 3. So this range, I'm stuck in between the negative 6 and the 3. So I have to be both bigger than negative 6. And notice if I've got an open circle around 3 and going off to the left, I need to be less than 3. So I'm both greater than negative 6 and less than 3. But we said we're kind of stuck or like sandwiched in between these two variables, or these two values. So another way to write an and statement in math, I could say the value of x is between the 3 and the negative 6. It's sandwiched in between these. So I like to think of this graph as like a sandwich. I'm stuck between these two options. On the other side, though, this is more of a split, right? I'm split off into one of two cases. So on the left, that inequality is pretty obvious. I've got a negative 7 with an open circle and an arrow pointing off to the left. Oops, sorry. So that tells me that my value of n could be less than negative 7. On my right branch, the value of n, hopefully you've caught on, is greater than or equal to 3. But think about this logically. Can I be both less than negative 7 and greater than or equal to 3? Well, no, then I'd have to be both negative and positive. That's impossible. So it's either less than negative 7 or greater than or equal to 3. Notice, by the way, I don't have a funky way to write a compound statement using or in the same way that I do for and. That's totally fine. That just means that every time we have an or, we're going to use our symbol or if you really want to, you can write the word or. But we want to get in the habit of using our symbolic representations. Take these next four. You've got a K, a D, an R, and a U. Take them and play around using what you've just seen. Can you tell me what two inequalities are being represented here? And are they joined by an and statement or an or statement? Go ahead. And come back. So for our K, I've got two inequalities here. Both of these I know the graphs of. Here I've got K is less than or equal to negative 8. I've got a closed circle and an arrow pointing off to the left. On the right, K is greater than or equal to 1. Right, my arrow's pointing off to the right, and I've got a closed circle, so they're my or equal to's. So I can't be both of these simultaneously. I'm on only one branch at a time. So this is an or statement. I cannot be both less than negative 8 and greater than 1. For this one up at the top right, notice here I've got a closed circle in between negative 4 and negative 2, so that's negative 3. I've got a closed circle at the 4, so I know that the values of D are sandwiched in between these two values, so I'll use my kind of sandwich compound notation. In this case, closed circle around both tells me that I need an or equal to. So the value of D must be greater than or equal to negative 3, while also being less than or equal to 4. This is an and statement. For our next one, also an and statement, this graph is a sandwich. What two values am I sandwiched between? Well, I've got an open circle around something between negative 1 and 0, so that's got to be negative 1/2. I've got a closed circle around the 2, so there's my upper boundary. The values of R are stuck between these two, and the 2 has a closed circle around it, so it needs an or equal to. So the values of R are greater than negative 1/2 and less than or equal to 2. And then finally, for our values of U, I've got two branches. So U here, if I kind of think here about what numbers I'm working with, I'm counting by thirds, you'll notice. So I've got 1/3 here. This is 2/3, and I'm getting smaller. Negative 1 is negative 3/3. So this guy, if you keep counting, would be negative 5/3. My values of U, right, I've got closed circle here, so it's less than or equal to negative 5/3. Or I've got a split graph. It's got to be an or. I could be greater than 0. Fantastic. So you now know how to turn the graph of a compound inequality into the inequality itself. Well, what if I want to put that down, flip it, and reverse it, and turn some inequalities into some graphs? So two last ones for the road. Let's take these, rewrite them in symbols. So you can write a compound inequality in symbols too, and then graph them on your number line. Give yourself a minute. See how far you get. Play around. Have fun. You've played with my witches, baubles, and trinkets. Let's put them together. So a number is more than -8 and no more than 4 and immediately tells me I should be using a sandwich. So for -8 and 4, first of all, I know the number is more than -8. So let's call that number n. You can use any variable you want. I'm going to use n. So I know that it's more than -8. So -8 is my lower boundary. So -8 has got to be below n. So I know more than gives me strictly greater. So n is greater than -8 here. And simultaneously, I must also be no more than. Well, that tells me n. If it can't be more than, it could be less than or equal to 4. And for our graph, I know how to graph here. The thing, by the way, that you'll see about my graphs of compound inequalities, again, you're more than welcome to label the entire number line. I personally don't like to. What I usually do, I'll just give myself 2 tick marks. One for the lower, one for the upper number. Around this -8, you tell me, is it going to be an open circle or a closed circle? 5, 4, 3, 2, 1. Well, I'm talking about values of n. In this case, they need to be greater than -8. No or equal to, it gets an open circle. Less than or equal to less than or equal to 4, right, it gets a closed circle. And then my values of n are sandwiched in between these two. So I'm going to fill in everything in between those two values. And last one for the road. A number is at most 0 or at least 3 halves. Well, my number, there's my n. If it's at most 0, that means that I could be less than or equal to, but I can't go above 0. Or, there's my symbol for or, at least. That tells me that my number, if it's at least, right, it could be greater than, it could be equal to, but it can't go lower than 3 halves. So on my number line, again, think smarter, not harder. Don't waste time. I'm going to give myself my 2 numbers, the 0 and 3 halves. I'm working with values of n, so maybe I'll label that on my number line. I know that around 0, I need a closed circle. I know that around 3 halves, I need a closed circle. 3 halves, I'm greater than or equal to, so I have an arrow going off to the right. I'm less than or equal to 0, so from the 0, I've got an arrow going off to the left. Split graph. Fantastic. So, first thing we're going to do tomorrow. I've graphed this. What do you think the next question is going to be? Well, I probably want to know, how would I write each of these in my set builder, my Smash Bros, and my interval notations? So if you want some brain food to consider, think about how you might translate these graphs using your set builder and your interval notation. The hint that I'll give you, if it ain't broke, don't fix it. All those ideas that we've talked about in the past for these notations are going to carry over again. Alrighty, my dears, thank you. As always, have a wonderful rest of your day. I'll see you in class 2.7. Take care, be good. Goodbye.